Hi, welcome to AuraML synthetic data generation platform, which you can use to generate synthetic dataset for various use cases. First, you go and click on generate dataset button and then select the environment you want to generate the data for. So we have various environment including warehouse, retail, digital cities and so on. So in this case, we are going to generate synthetic data for a warehouse use case that we have worked with one of our customers. So what we are going to do is we are going to create a 3D environment. So we are going to load up a live 3D environment within your web browser, which you can then configure to according to your use case and then generate synthetic data for it. For example, in this use case, you see a warehouse with all the boxes, racks, pallets, forklifts, ladder, conveyor belt, robotic arm, and so on to simulate your real world environment. So once we have created that, then you can configure your lighting conditions. So on the left side, you see there are different panels including hue, saturation, temperature, intensity. So you can set up the min and max values of these values. And let's say if you want to generate 10,000 images, then these values will be randomized automatically within those 10,000 images. So as we can see, we can also have some dark lighting conditions as requested by our customers because you want to get a very robust computer vision model which you need to train. Second, we can also add robots to our warehouse, simply drawing a spline or a line which will be following the path of the robot. So once you have specified the path of the robot, then you can specify the count of those robots. For example, in this case, 3 robots of a type and 3 robots of other type. You can just hit the apply button and you can see those robots moving within the warehouse as per your requirements. So that is how simply you can create the path for the robots within the warehouse. Third comes the people tab, where you can spawn workers in the warehouse. So in this case, you are going to spawn different male, female workers in the warehouse by specifying a rectangular area from the top view. And in this case, we are going to spawn 4 men and 5 women in a particular area. So these people would have different skin color, different hair type, different build type, and also it can be customized according to your use case as per your requirements. So once we have specified the lighting condition, robots and people, we can also spawn our own 3D objects within the scene which we need to get do the detection for using the computer vision model. So for that, simply we would be adding a 3D region within the warehouse to spawn objects at randomized location according to the configuration provided. So we can see we have already loaded up the whole 3D environment with people, robots. Now let's go to spawn 3D objects. So for that, we just need to hit the plus button. We specify a cuboid within the 3D region, including the length, breadth, and height. So once we have specified this 3D region, we can then select the objects that we want to spawn within this 3D region. So in this case, we have different kind of boxes, fire extinguisher. We can also add any of our own objects to this platform to get it spawned within the 3D volume. Now we are specifying the count, the min and max count of the objects, and we can just hit the randomize button to see those boxes at randomized location according to how it happens in the real world. Once we are happy with the objects that we wanted to spawn, we can also specify the exact camera view from which we would like to get the synthetic data set from. So for that, we are going to go to the camera tab. So in camera tab, we can see there are various configurations including resolution, field of view, and also roll pitch here. And also we can pilot the camera anywhere in the warehouse. So let's say if there's a CCTV use case where we want to maybe detect safety monitoring of the warehouse and we want to detect if the workers are wearing helmets or vests. So we can specify a CCTV kind of viewpoint along with the field of view roll pitch here. We also have the randomization feature in roll pitch here where you can specify the min and max value so that it can get randomized viewpoints along with the area that you want to view. And also we can enable dirt mask on the camera lens. So in real world cases, what happens, there's a layer of dust or a cobweb on top of a camera lens. So we can also specify that layer of dirt mask according to the intensity, min and max intensity that we would like to have. Once we are satisfied with the camera viewpoint and the dirt mask, then we can go to the annotation tab. We support COCO and YOLO format and also different type of annotation, including bounding box, instance segmentation, semantic, depth, normal. Anything you would be wanting, we have that. And then finally you specify number of images, sample per pixel, and simply click on generate dataset button. Once you do that, the request goes to our backend, it gets queued, and also once the dataset is generated, you get an email, and then you can come back to our data management section to visualize those generated images. So in this case, we have this warehouse images which got generated, and you can see like how realistic images we can generate using our end-to-end pipeline of synthetic data generation. And also we can visualize other annotated images such as normal, we have depth maps, we have semantic segmentation, instant segmentation. All that can be visualized, and then you can simply click on download data button to download the dataset and use it to train your computer vision model. So in this particular use case of semantic and instance mask, you can just imagine how much time it could have taken by a human to just annotate these kind of images, drawing polygons around each and every image. But in this case, everything is automated. You just have to click on the download dataset button, and it is ready to go to use and train your computer vision model. So that is it about our synthetic data platform that we have built at AuraML.